Colleagues, you got it wrong. A round of applause. We talk about maths. It's maths that we're talking about. Serious, you got it wrong. Around it. It is a circle of applause. You can do it clockwise or you can do it anti-clockwise. Look, I'm a teaching and learning specialist. I've got this. The one that they were using is outdated. This is the latest. It was purchased by the University of KwaZulu-Natal. Look, colleagues, I'm going to talk about demystifying and decolonizing mathematics. This is very, very important. And please, you must take notes. I heard that we have subject advisors here, with teachers here. You must take notes. Because the methods that we are using to teach these subjects, the methods that we are using are wrong. That is why students are not performing. We are teaching the way we were taught. Our learners, we encourage them to celebrate the Valentine's Day. Why? Why the Valentine's Day? HOD, Mr. Masibugo, Mr. Makatin, and please, we have to change. No Valentine's Day. We need to have Love Maths Day. Love Maths Day. Learners must celebrate mathematics on the 14th of February. Each year, I visit a school and we conduct a maths show with my son. We call it Love Maths Day. We have visited quite a number of schools. Well, let me go straight to the presentation. It looks as if my thing is not working. No, you know what? The other speakers were pointing this thing here, but you are supposed to point it here. This one, you point it there. All right. Colleagues, mathematics is not difficult, as we normally say. We say mathematics is difficult. No. Mathematics challenges our creative brain. It must be communicated creatively. We need new techniques. New techniques must be used to make this subject interesting. Let's put the excitement back into mathematics. Learning is 24/7. We talk about synchronous learning, we talk about asynchronous learning now. Synchronous learning is when you are with your students as your teacher. It can be face-to-face or it can be online. But asynchronous, you can study anywhere, anytime. Why our learners are not doing the asynchronous? We only focus on synchronous learning. That is wrong. We have to change the way we teach. Please, do not teach the way you were taught, because my teacher taught me like this, therefore this is the method that I'm going to use. No. We talk about the blended learning approach, the flipped classroom approach. If you're going to introduce a lesson perhaps tomorrow, you can give your students, send them a link using Google Drive, using WhatsApp, or directing them to YouTube to watch a video, and you can ask questions based on that. And you ask lower order questions. We talk about the flipped classroom approach now. Use blended learning, your traditional teaching methods, combine them with technology. It's not happening at school level. Mathematics, as a teacher, you only teach one method. Why teach one method? Because there are 5 methods, 7 methods, 10 methods to solve a problem. So that the learner can choose a method that suits him or her. Please, we need to also ask high-order questions during the content delivery phase. Some teachers, they go straight to the content delivery phase. They do not go to the introduction where we talk about curiosity and concentration. Let us not undermine the kids. We have to know we talk about baseline assessment. We must move from known to the unknown. Then there you ask lower order questions, and then content delivery phase. Then we talk about high order questions. We talk about constructivism. Learners must construct the knowledge. You as a teacher, you must guide the students. The learner-centered approach must dominate. We talk about connectivism. That's why now we talk about technology. And collaboration is very, very important. And communication, there must be creativity and critical thinking, and there must be choice. I must choose a method that I like, then I'm going to take this method. As a maths teacher, if there are 10 or 7 methods, teach those 7 methods. The WhatsApp is very, very important. At university, we have the learning management system at university. What about at school level? We do not have a learning management system, therefore we can use WhatsApp. WhatsApp could be used as a for discussion forum. It can be for discussion forum when you discuss with your students. Students can also assist each other. We talk about student-to-student support. We also talk about the teacher-to-student support. And then consultations. At university we have consultations, we have tutorials. Why we do not have at school level? Consultation can be one-to-one or one-to-many. The chalkboard summary, when you teach your maths, you delete everything, and then you say your kids must do, you give them problems to go and solve at home. But you deleted the chalkboard summary. They must have a book of essentials. We are going to take the chalkboard summary so that at home when they do, they know, okay. And if there is no book of essentials, there must be a USB or email the material to them or send via WhatsApp. That's a chance of that. John Dewey says, if we teach, that you see, this is what is happening in my class when I teach at university. My students, they, like you are doing. That's why I got an award at the university. I got the DTA, the Distinguished Teacher Award. Even national, I was in the top 10. Give job. My class is always full. I'm telling you, it's always full. You see, John Dewey says, if we teach today's students as we taught yesterday, we rob them of tomorrow. Technology won't replace teachers, but teachers who use technology will probably replace teachers who do not. Department of Education, use technology. It's very, very important. Please, let us use technology. Mathematics is not abstract. If you read the Bible, you find mathematics. Mathematics is there. Luke 6 verse 29. Last Friday, my pastor read the scripture. And then my pastor said, if someone slaps you on one cheek, turn to him the other also. I said, Pastor, that's my territory. It's not yours. And then I said, Pastor, hello. Now what we are talking about is mathematics. In maths, whatever you do on the left-hand side, you must also do on the right-hand side. Let's change the way we teach maths. Let's change the way we teach maths. Here's another one, Exodus. Moses went up the mountain to fetch the 10 commandments. Went up the mountain. Hey, what is that? In mathematics, went up ascending order, and went down descending order. Jesus Christ, the cross. Hey, we use this in maths. This is the Cartesian plane. We have the 4 quadrants there. Yes, this is the Cartesian plane. The founder is religious Cartes. That's why we talk about the Cartesian plane. Yeah. And in accounting, we talk about this. But in accounting, you see, Jesus was crucified on the cross, But in accounting, we say, no, this is a T account. We say this is a T. This is Msizi, this is Msizi, if you see my face, but we write the name, this is Msizi's account. If I receive mine, I receive this side. If I pay this side. In physical science, we also use the Cartesian plane as well. In economics, we also use the Cartesian plane, but in economics, we only use the first quadrant because we call it the economic relevant rating. Everything is positive there. The road science geometry say, you are teaching geometry, you are teaching grade 8, you are teaching grade 9, you are teaching grade 10, you are teaching them quadrilaterals. Quads are used here. Look at the triangle over there, the geometric shapes. I only look at the hexagon, the pentagon, the nonagon are there. Look at the trapezia. Look at this one, the rhombus over there. Look at the straight lines. Look at the broken lines. We use that in maths. Pi. Hello. Pi, this is pi. This is 22/7. That's why it's from this. It's from 22/7, it's pi. The rectangular one is not a pi. A pi must be a circle, It must be 3,14. The circumference divided by the diameter must give you 3.14. Even if the circle is big, but if you divide the circumference by the diameter, you are going to get 3.14, that's why we call it a pi. The rectangular one, we call it a pastry, it's not a pie. The semicircular one is a pastry, it's not a pie, but we call it a pie. No, the circular one, we call it a pie. By the way, I'm from UKZN. At home we talk maths. I encourage my kids to talk maths. Even my wife, maths. Before you eat, talk maths. Yesterday, it was fish and chips. And I told them they were eating maths. And then they said, please explain. I said to them, please give me the pen and the paper. I said, okay, fine. Fish, it's a look at the cubic curve with the positive gradient, where A is positive, Where A is positive, We have the stationary points, okay? Yeah. And here is another one, where A is negative, Can you see the last part, And then now you get what? You get a fish. I told them to fish. They said to me, now what about chips? I said, fine. I said, please give me 2. I said, parallel lines, transversal, vertical opposite angles, corresponding angles, alternate angles, co-interior angles, Yes. When we teach, colleagues here, we're talking about the linear equations, the quadratic. The quads, grade R, grade 1, grade 2, grade 3, they talk about the quadrilaterals. Look, when we teach quadratic equations, why don't we even show them the figure, the quadratic? The figure. Why don't we? Yes, we do show them the function, but we do not show them that, hey, now you've got your factors. Your factors, now we talk about length times breadth. That is the area. If the factors are the same, it means it's a square, because it's L squared. But we do not show, it is not even in our books as well. We talk about CPA, the concrete pictorial abstract model. We want the pictorial. Cater for all types of students. This one is the abstract. We want the pictorial one as well. Look at the linear equation. The linear equation, even the exponent there, it's 1. That's why you've got 1 factor. Look here, the quadratic, the highest exponent is 2. That's why you have 2 factors. Cubic curves. Cubes, grade R, they play using cubes. Yeah, grade 1, grade 2, cubes. Look at the cube over there. It's from that, the cubic equation. You get your cubic function. Yeah. Show them that, hey, you also get your cue. Let's change the way we teach. Did I greet you? No. I didn't. I'm so sorry. I'm so sorry. Hello, colleagues. How are you today? You know what? My students, I do not encourage them to say I'm fine. Fine like a fine salt? No. I encourage my students to say I'm positive. Even indicate with this hand, I'm positive. No, I'm negative. If it is negative, it means there is a problem. Hey, I'm greater today. Can you see the sign greater? Can you see the greater, eh? Yes, because this hand is strong, I'm greater today. No, today I'm less, eh? I'm less than 0. Where is 0? Yeah, my head is 0, the neutral point. I'm equal. The left hand side is equal to the right hand side. No, I'm not equal. Oh, by the way, this is number line. Positive numbers, negative numbers, your head is 0, the neutral point. Say, I'm rational today, I'm just like the square root of 4. No, say I'm irrational today. No, say I'm proper like a proper fraction today. No, I'm improper today. Say I'm 100%, say I'm less than 100. Say I'm like a straight line. If you want my gradient is the same at any point. No, today say I'm like a curve. If you want my gradient, you must use calculus. Who created the numbers? Let me ask you a question now. Yeah? Who created the numbers? The answer that I normally get, they say Arab, Egyptians, Greeks, Indians, God. No. My father created the numbers. He was brilliant. I'm telling you, he was brilliant. You know what? He started with 0 up to 4. He said, we're going to write 0, 1, 2, 3, 4 like that. And then he said, to get a 5, you must take a 2, turn it upside down. Can you see now it's a 5, eh? To get a 6, you must take a 1 and make a 0 small. And then to get a 7, take a 4 and write it like that. To get an 8, complete your 3, take a 3 and complete it. To get a 9, take a 6 and turn it upside down. He was brilliant. When I was doing grade 1, I had a problem with the multiplication of 9. He said, no, the numbers that I developed, please write the numbers from 0 up to 9. I did that. And he asked me, he said, now, please reverse, start from 9 to 0. I did that. Now he asked me a question, what do you notice? I said, oh, this is a multiplication of 9. 9 times 1 is 9, 9 times 2 is 80, 9 times 2 is 27, 9 times 10 is 90. And then he asked me another question, what do you notice? If you add the answer, you get 9. 0 plus 9 is a 9, 1 plus 9, 8 is a 9, 2 plus 7 is a 9, 9 plus 0 is a 9. He asked me another question, what do you notice? I said, if you multiply any number by 9, if you add the answer, you get a multiple of 9. 9 times 11 is 99. If you add 9 plus 9 is 18. 18 is a multiple of 9. 9 times 111 is 9999. If you add 9 plus 9 plus 9 is 27. 27 is a multiple of 9. Oh, I was busy working on geometry. And my father said, hey, no. Remember your grade R, grade 1, grade 2, vowels, the traditional way of writing the vowels. He said to me, no, that's geometry. Look, A-E-I-O-U, A-E-I-O-U. Look at your circle. Can you see your circle plus your line? A line touches the circle, which is a tangent. Are you there? Yes. Can you see E, the semicircle over there? This is circle geometry. If you can show your students this thing, I'm telling you, they won't have a problem with circle geometry, even solving the geometric riders. Look at this thing. Now let's look, if you put the triangle inside, it's a tan chord theorem. Can you see the tan chord theorem, eh? The angle between the tangent and chord is equal to the alternate segment, eh? Yes, tan chord theorem. If you, the diameter as well as your radius is perpendicular. Tan is perpendicular to the diameter. Look, line from the center is perpendicular to the chord. And your two tangents from the same points are equal. There, the theorems are there. Look at your E. The angle at the circumference is 90 degrees. The angle at the center is twice the angle at the circumference. Your I is your straight line, 180 degrees, adjacent supplementary angles. Your O, if you put a quad inside, you put a quad, we talk about cyclic quad. The opposite angles are supplementary. The opposite angles of the cyclic quad are supplementary. Your U, you put a circle and you close your U, the exterior angle is called to the interior opposite. Angle subtended by the chord and the arc are equal. We're talking about vowels. What about the consonants? Consonants are also geometry. Also geometry. Look at the word maths. We can even play with this word. Mathematics is here. Maths. You can get your geometry here. Look at your M. Your M. Remember the congruence of triangles, eh? Yes. 90, 80 degrees, hypotenuse side, angle side, angle side. Yeah, side. Hey, the exterior angle is equal to the sum of the two interior opposite angles. 90 degrees there. Alternate angles, corresponding angles E, corresponding angles, and here, angles subtended by the chord and the arc are equal. Similarity, the triangles are similar, and we talk about the proportionality theorem. The diameter is perpendicular to the tangent, the straight line. C is for complementary angles. Adjacent complementary angles add up to 90 degrees. S is for supplementary angles. Adjacent supplementary angles add up to 180 degrees. Is this in the books? No, it's not. In accounting, the father and the founder of the subject, accounting, is a mathematician. That is why in accounting we talk about accounting equations. And at school level, we encourage kids to memorize the rules, of which is wrong. There's no need of memorizing the rules. No need of memorizing the rules, you just use maths. Look at your A. A, this side, is on the left-hand side. Therefore, A is positive there. It's positive on the left-hand side. If you transpose A to the right-hand side, the sign changes to negative. And O is on the right-hand side, it's positive there, it's a positive. If you transpose to the left-hand side, the sign is negative. And N is positive on the right-hand side, you transpose to the left-hand side, it's negative. No need for memorizing. An egg, you can even use an egg. Assets are containing, as you can see, the shell is containing two things. Even the assets containing two things. The yellow part is the owner's equity, the liquid part, liabilities. The owner of the business is interested here, the yellow part, because this is healthy. This is owner's wealth. Please, we need to infuse maths into accounting. We need to integrate mathematics. That's why kids are running away. You know what? They take mathematical literacy. You know what? For accounting, we only need GET maths. Accounting, we need GET maths, not FET mathematics. I've written a study guide with my son, the accounting mathematical calculations made simple. It's GET maths that we are using, which is part of mathematical literacy as well. I was challenged by a student. A student asked me a question, Prof, why in accounting we debit and credit, credit and debit? Why don't we debit and debit, credit and credit? I had to explain. Then I said to this student, I'm Msizi, my wife is native. I gave her, this hand is strong, this one is weak. So I gave her 5,000 at the end of the month. I used my weak hand. She received it with this one, the strong one. Oh, if the first account is credited, the second one must be debited. So that's why in accounting we don't debit, credit. Oh, she gave me back 2,000 rand, and I received with this one as well, the strong one. So that's why we talk about the double entry system. We use it in accounting. The Pythagoras theorem, I use Pythagoras theorem to explain the process how to become a chartered accountant, to become a CA. To become a CA, you must study at university, BCom accounting for 3 years, you add another year for your CTA, also called honors in accounting. Another year is 4 years, for the area of this square is 16 square meters. You must join one of the accounting firms for training. Training is 3 years, but in your first In January, you write SAICA exam. SAICA exam in the 5th year. So that's why there we have 5 years in the 5th year, you write, and then the square is 25 square meters. And the training is 3 years, that's why we have the 9 square meters. If you add 16 plus 9, you get 25. I'm using the 3, 4, 5 triangle. Right-angled triangle. The process how to become a CA, and then you register with SAICA as a chartered accountant in South Africa. We use maths in physical science. We work in silos. Teachers do not talk. Why? Teachers, accounting teacher, talk to your maths. Science teacher, talk to your maths teacher. We work in silos. Why? We talk about, we need to break down silos. We need to teach across the curriculum, please. I've written an opinion piece. Teaching mathematics needs creativity and a touch of magic. Right? I was talked about this time. Right? Please read. It's interesting. And my son wrote a poem. He was doing grade. It was grade 9, if I'm not mistaken. Yeah. But now he's a teacher teaching maths at George Campbell High School. My expression for the love of mathematics. I'm a mathematician, I'm good with numbers, I'm good with figures, I'm good with algebra, I'm good with geometry, I'm good with trigonometry. They call you a killer subject. They hate you, they have a negative attitude towards you, they avoid what is difficult, they go for what is easy. Tell them you are everything. Tell them the world is mathematics. Tell them scientists use you. Tell them engineers use you. Tell them accountants use you. Tell them everyone uses you. You have many names. They call it core mathematics. They call it pure science. They call it mathematics science. You need strong-minded learners. You need industrious learners. You need innovative learners. You help us to think outside the box. You help us to think critically. You are my friend, mathematics. Your sister, mathematical literacy, is my friend too. She takes care of those who are afraid of you. Your relatives are my friends too. Anti-science, anti-geography, nephew, accounting, economics. The future of the country must not be compromised. Fellow learners, go for mathematics. Your future lies in mathematics. Thank you very much.